volume. So surface area is how much area completely covers the surface of an object. So you guys in 6th grade probably just talked about area. When we talk about just area, what are we talking about? What kinds of shapes? Justin?
Circle, square.
Circle, square, trapezoid, rhombus, triangle. But what?
Good morning. Angelina Hipsley, please come to the office. Angelina Hipsley to the office, please.
What do
Thank
those
you.
all have in common? Anthony? They're two-dimensional. So this unit is taking three-dimensional objects and breaking them apart, like visually, not really, but thinking how we break them apart to look at what would the total area when we flatten it out be. Now, we say that each of these are 1 unit, each edge thing. So this is 3 by 3. Each of these little boxes is going to be 1 square unit. So on the blue face, what's the area of the blue face? How many squares? 9, right? So that would be 9 units squared. How many of those faces do we have? 6. So we could do that by saying, I know that 1 face is 9. I know that I have 6 faces. 6 times 9, I get my area of 54. Whatever your units are, then squared, because area always has to be squared. So who's going to Chicago? So the bean is actually like over 100, I think it's over 170 pieces of metal, all connected together, all welded, and then polished until you cannot see a single edge. So let's imagine we've got this structure up here. We use square pieces of metal, and we're going to polish it. We know that 1 square foot of this cube-shaped sculpture takes 10 minutes to polish, so 10 minutes for every square foot. We know that this is 5 feet long, so if I count this up, I can figure out each of these squares is 1 foot squared. We want to figure out what is the total surface area of this cube. So take a moment on your own. You can talk with partners or whatever you need. Try to figure out what is the surface area of this cube. Whole cube, whole thing. That is a piece of art they're going to put in front of the school. Say you got in trouble, now you have to polish the whole thing. We don't have punitive things like that here, but that would be like one of the old school, like, oh yeah, now you get to polish this.
But we're not actually putting a statue outside of school, are we?
No, but the bean is just sheets of metal. If you go to Chicago, you're going to see the bean. It's just sheets of metal welded together. You can't see any seams. Like one of the challenges is try to find any seam on it. Like, and in the middle of it, it goes up into itself and it kind of has this weird angle up it. Like, it's a mirror. For everything that you can tell, it looks mirrored.
I've seen pictures of that.
Yeah, but it's not.
It's really cool.
It's just polished metal. It's just polished steel. So this has 6 identical faces. Jack, when you start thinking about this, what do you think first? We relate this to how we did the Rubik's Cube. What's the first thing that we talked about with the Rubik's Cube? So I already wrote down, we know because it's a cube, it's identical, right? Every face is identical. Xavier, what would we want to do next?
Look at all the little faces and they're on each identical face.
So if I know that I have 6 identical faces, let's just first deal with one face. So on one face, what do I know about the one face of this up here, Hayden? It's 5 by 5. This would be written like this, and this is why I hate that we can't use the x is multiplication anymore. When you're talking about dimensions, we use the x to mean by. We've got length by, width by, height by. Like, so this really, when we talk about it, means by, but that just tells me multiply. So that tells me that one face is 25 feet squared. 5 feet by 5 feet. If I count these little squares, I will have 25 little squares. So for the whole thing, to calculate my surface area, what do I need to do? Izzy? So we're going to say I have 25, but I actually have 6 faces of that, which will give me a total surface area of 150 feet squared. Now, if it takes you 10 minutes to polish 1 square foot, so to figure out our time, what would we need to do? Andrew?
So you would multiply 150 by 10 cents. Each square foot is polish is 10 minutes.
So that will take us 1,500 minutes. Why would we divide by 60? To figure it out in hours, we divide by 60. How many hours? That'll take 25 hours.
An entire day.
So literally, if you didn't stop, no bathroom breaks, no lunch, no dinner, no naps, it takes you longer than all day. Now, if you're smart, like, I forget if it was Huck Finn or if it was, I think it was Tom Sawyer who was supposed to paint the fence. What did Tom Sawyer do? Trick his friends into doing it for him, right? Man, polishing this sculpture is so fun. I wish you could have as much fun as I'm having. I guess I could share with you. So, if this was going to take you 25 hours, recruit some friends. Every person you recruit, that will divide out how long it will actually take. So maybe you can order pizza or something and pay your friends to come help out. So, in a prism, I'm trying to wrap this up by like 10 after, 12 after, so we still have a good 20 minutes to work on the test. In any prism, so that situation we just did was a cube. That's a very specific prism. Actually, if we jump down right here, here's what we just did. Surface area of a cube, and I'd love for you to rewrite this because it will help put it into your memory. Surface area of a cube, we have 6 faces times the s squared. The s is our side length. Why do we square the s? If we have a side length, we have a cube, Flynn?
Because it's in units.
Yeah, and what are my faces? I have 6 faces, and each of those faces is a, if it's a cube, what do I know about my faces?
It's like on the tip of my tongue.
What kind of shape is the face?
Square.
Square! That's why we square it. We square it because the face is a square. That's literally why we use the function square. The face is a square. That does not work unless it's a square. So if you didn't have a cube, let's say you had any prism, what makes a prism a prism? I've got tons of examples. You guys can come up and play with these whenever you want. Just make sure all the pieces get back here. So we've got our cube. It is a prism, but it's a specific prism. It's like how a square is a rectangle, but a rectangle is not a square necessarily. So, prism. This is a prism. but now it has triangles. This is a prism, but now it's got rectangles and it's got squares. So what makes a prism a prism? So you might off to the side somewhere, because we don't really know this yet. A prism has identical base shapes, or identical bases on top and bottom. With rectangles connected. Sorry, I ran out of space here. Identical bases on top and bottom with rectangles connecting them. So, this rectangles connecting, what are the rectangles connecting? Triangles. This is a triangular prism. This, rectangles connecting, what type of prism? What's a square-based prism? Which is not a cube. But a cube is also a square-based prism. So, this is a square-based prism. It's also a cube. This is a square-based prism, but it's not a cube. But now, what if I lay it like this? It's still a prism. Is it still necessarily a square-based prism?
Yeah.
Depends, actually. It can be.
The square's still there, though.
The square's still here, though. But are squares rectangles? So couldn't these be the rectangles connecting my bottom to my top?
Yeah.
So what if now this is my bottom and this is my top? What sort of prism is it? What's the base shape?
Rectangle.
So now it's a rectangular prism. So be careful. You have to identify what's the base. It doesn't have to be the bottom. This is a triangular prism, right? I've got a triangle on bottom, triangle on top. If I lay it on its side, it's still a triangular prism. It cannot change name. Because if I look at the rectangle being on the bottom, is there another rectangle on top? No, the top is a straight line. I need to be able to manipulate this to the point that I can look at it. Bottom, top, identical shapes connected by rectangles. So that's what makes a prism. So then we get our formula to calculate the lateral area. What does lateral mean? Well, lateral means around. So, if you would like to identify, I would if I was you. The lateral area is the area around. Another way to think about this is not including the bases. Not including bases. Down before I wrote it down? Yeah. So, you don't have to follow these formulas. I don't care how you do these. I'm just trying to make your life easier. If I want to calculate all three of these rectangles around my prism, because I've got a triangle on bottom, a triangle on top, they act differently than my rectangles. All I have to do is figure out how far around does this go, and multiply it by how far the distance between them is. Because when I blow this up, what's it called when I look at the 2D of a 3D? It's a net. When I look at the net, I've got my triangle on top, my triangle on bottom, and all three sides just make one giant rectangle. So that giant rectangle, ignore those triangles. This length is what? That's the perimeter around the triangle. This distance, how tall it is the distance between the triangles. So this perimeter, this length, is just how far around is your triangle. That tells you how big your rectangle is. How tall it is just how far is there between them. So on any prism, that will work as long as you identify the base correctly. So then to find the surface area, we just have to bring in with the bases. So the only difference there is we have to double the base because there's two of them. So we have to double the base because there's two of them. So our lateral area, we would have already calculated. However you want. You can either use the formula or just add up the faces. So you could up here say, or add up the faces. That is also an option that works equally as well. It's slightly harder. Actually, no. It takes slightly more time. I don't think it's harder, but it does take more time. And then I got to do total area. I got to include both of the bases. Any questions on these? Biggest thing is identifying what kind of prism it is, and it will be told to you. So really quickly, we're going to run these 4 examples, and then we'll probably call that a day. So let's practice the first one using the formula that we've been given. So let's do our lateral area using that perimeter times height. So set up, please. Lateral area will be perimeter times height. We are going to use the bottom as our base. So when I look here at my perimeter, well, how do I find the perimeter of that base? How do I find perimeter? What is perimeter? Around, right? So kind of like circumference, it's the distance around. So, Brandon, my distance around this rectangle, what are the lengths of this rectangle? 9 and 2. So I can either do 9 plus 2 plus 9 plus 2, or I can double the 9 and double the 2. Either way, that perimeter comes out to be 22. So up here in my lateral area formula, I'm going to use that 22. Now what is the height between the bases? Bella, what do you got? Height between the bases. If we're using the bottom as the base, and the top is another base.
3 feet.
Yeah, 3 feet. So that now tells me my lateral area is 66. Label it feet squared. Now, Michaela, we just said that we're leaving the bottom as the base. So to calculate my big B, or the area of the base, do not use a small b. We specifically use capital B to mean area of the base. What are the dimensions of that rectangle for my base? If we use this rectangle, what are those dimensions? You know it? How long is it? 9 feet. How deep does it go? So our dimensions for big B are 9 times 2, which gives me 18 feet squared. To wrap it all together, and this is the step people forget, I gotta double this, because there's 2 of them. So to find surface area, I like to double my big B first, and then add my lateral area. You can switch the order around. You can do 66, then plus 2 times 18. Doesn't matter, you just got to double the base area, add the lateral area. This will be 36 plus 66 is 102. Anyone got verification for me? 66 and 36. We get 90, and then 12 should be 102. So try, actually, this is a good spot. If you want to go ahead and try the other ones, you totally can. Otherwise, I'm going to pass out our masteries, and we will pick up here probably tomorrow. We want to make sure that we get the masteries done. Here's the deal. The homework still does not need to be done. We have not covered this all the way. If you've done it, sweet, good for you, but the homework does not need to be done. These tests you will not have back before Discovery Day. I did not give you any feedback for over the weekend because I spent the whole week with my family. They were in town visiting, so that was nice. But you will not